Hello, we're going to start with workshop number 7. We're going to call it tension fitting. Then we're going to have a tolerance based on model with analysis code MSC Nastran with type structural. The next step is to create a surface. We're going to hit geometry and we're going to select the XYZ and we're going to enter the coordinates 5, 2, and 0. And for the origin coordinates, we're going to select this 0, 0, 0 coordinates and apply it. We're going to increase the point size icon to show all points enlarged. We're going to point ID list 7. Then we're going to enter the for translation vector 0, 0.5, 0, and 0. Then we're going to select the left corner. Ah, cabrón, el tic. Qué pedo, qué pedo, qué pedo. Now we're going to click increase point size with point ID 7 with the direction vector of 0.5, 0, and 0 with the point list point number 2. We're going to apply it and then we're going to enter the vector 0, 0.5, and 0. And we're going to select the bottom right corner with 0.4 and apply it. Now we're going to create a curve by connecting the two translated points and break the surface with a curve. The starting point list is going to be 0.6 and the ending point is going to be 0.5. And apply. Now we're going to break the surface and delete the upper portion of the original surface. We're going to turn auto executed off and we're going to select the rectangular surface for the surface list and the slope curve for the break curve list. We're going to apply it and we're going to click the refresh graphics icon. Now we're going to delete the upper surface we're going to click on the triangular surface for the surface list. And apply it. Now we're going to create a solid by extruding the surface in the Z direction. We're going to make sure that meshable solid icon is selected. We're going to enter a 0, 0, 2 for the translation vector. And we're going to select the surface 2 in the surface list box. Now we're going to click ISO 1 view. And then we're going to click the smooth shaded icon. Next we're going to create cylinders using points as base centers and then create holes by subtracting them from the solid. We're going to click smooth shaded icon. Then we're going to geometry, create solid primitive. We're going to select the cylinder icon and we're going to enter a -1 for height list and 0.125 for radius list. Then we're going to select the 3 translated points for base center point list. And we're going to enter a chord 0.2 for axis list and click apply. Next we're going to geometry, edit solid boolean. And we're going to select the subtract icon. Then we're going to select tension fitting solid 1 as target solid. Then we're going to shift click all 3 cylinders for subtracting solid list. The next step is to create a cylinder to imprint tension fitting. We're going to create a point in the center of the large hole in order to create the cylinder to imprint onto the solid. First of all, we're going to click wireframe icon. Then we're going to geometry, create point and arc center. Then we're going to select the larger hole edge. And apply. Then we're going to Geometry, create solid primitive, and select the cylinder icon. Then we're going to enter 1.0 for height list, and 0371 for radius list. Then we're going to click on point in the center of the large hole, and enter chord 0.1. Then we're going to click apply, and finally select smooth shaded icon. Now we're going to use the cylinder to imprint the solid and then delete the cylinder, resulting in the finished solid. We're going to Geometry, Edit Solid Imprint, and we're going to select the tension fitting for the solid list A. Next, we're going to select the cylinder for the solid to imprint list B. Now we're going to delete the cylinder and make sure imprint method was completed. We're going to delete solid, and we're going to select the cylinder for solid list. Next, we're going to apply. Now we're going to create a TED mesh for the tension fitting. We're going to Elements, Create Mesh Solid, and we're going to make sure TED mesh and TED 10 are all selected. We're going to click on Input List and select the solid. Then we're going to remove the check for automatic calculation, and we're going to enter a quarter of unit for global edge length. Then apply. Now we're going to create the loads and constraints for the model. First of all, we're going to click Smooth Shaded icon, then we're going to Loads BCs, and we're going to create total load and element uniform. Then we're going to enter force as the new set name, and we're going to click Input Data. We're going to select the vertical solid face created by imprinting at a larger hole. We're going to click Add, OK, and Apply. Now we're going to select the application region, and we're going to select the vertical solid face created by imprinting at a larger hole, and we're going to click Add, and OK. Then apply. Now we're going to create the constraints at the base holes. We're going to load BCs, create displacements nodal. Then we're going to enter fixed as a new set name. We're going to click on input data, and we're going to enter 000 for translation only and click OK. Then we're going to click on select application region, and we're going to click on select geometry entities. We're going to select surface or face icon, and then we're going to shift click the cylindrical faces of the three holes at the base and click add. Then OK and apply. Then we're going to select the three holes and add them. The next step is to create material properties. We're going to create the material properties for the model. We're going to materials, create isotropic metal input, and we're going to enter aluminum for material name. We're going to click input properties and then enter 10 times e to the 6 for elastic modulus and 0.3 for Poisson radius. We're going to click OK and apply it. Now we're going to create 3D elements properties for the tension fitting. We're going to properties, create 3D solid. We're going to enter 3D text for property set names. We're going to select input properties. Then we're going to mat prop name, select aluminum, and click OK. Then we're going to application region, select entire solid by dragging a box around it and click add. Now we're going to check the load case default to make sure that the load and constraints are selected. We're going to load cases and modify. Then we're going to click on the load case name default. Then we're going to check to see that both the load and constraints are assigned. then click cancel. Now we're going to run the analysis. We're going to analyze entire model and full run. Then we're going to click translation parameters. We're going to solution type and make sure that linear static is checked. Then we click OK and apply. Now we're going to attach the XDB file and access the results. We're going to access results, attach XDB and result entities. Then we're going to click select results file and select tension fitting XDB. The next step is to create a fillet on the inner edges of the solid. We're going to make sure that the constant radius icon is selected. Then we're going to enter a quarter of unit for constant radius. And we're going to make sure edges of solid icon are selected. Then we're going to click on the solid edge list and select the 5 edges on the inside of the solid. Then we're going to apply it. And we have the fillets. The next step is to create the holes for the tension fitting by creating primitive solids that pass through the solid, then subtracting them. We're going to select the cylinder icon and we're going to enter 2.0 for the height and 0.25 for the radius. Next we're going to enter a -1, 1.25 and 1 for the base center point list and chord 0.1 for the axis list. We're going to apply it. Then we're going to edit, solid boolean, and we're going to select that subtract icon. Then we're going to select the tension fitting for the target solid. Next we're going to select the subtracting solid list, and that's the cylinder. Then we're going to apply it. Next we're going to create the points where the 3 bottom holes will be placed by translating an existing point and then translating again. We're going to click the wireframe icon and then we're going to hit geometry, transform, point and translate. We're going to enter 0, 0 and -0.5 for the translation vector. We're going to select point at base edge of fillet and we're going to apply. Then we're going to enter a -0.7500 for translation vector. And we're going to select the translated point apply it. Next, we're going to enter 2 for repeat count. And we're going to select the translated point. And apply.